Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I am Muhsin bin Munir. So this is my research poster for the International Multidisciplinary Innovation Competition IMIC 2021. So my research title is Fabrication of Synthesized Carbon Nanofibers or 3D printed honeycomb structure as electromagnetic wave absorber. The usage of electronic devices is efficacious in our life nowadays. The pandemic of COVID-19 needs us to be distanced where online classes and online meetings are held regularly. These electronic devices produces an electromagnetic wave that affects our health. Therefore, this research constructs a prototype that is capable to absorb and reduce the electromagnetic interference by using the synthesized carbon nanofibers as the filler with the 3D printed honeycomb structure as the interface. The mixture of sintered nickel, zinc ferrite and carbonyl iron are used as the catalyst to grow carbon nanofibers via chemical vapor deposition (CVD) method. The samples will be further incorporated into epoxy resin and 3D printed with honeycomb structure at thicknesses fixed to 1 mm and 2 mm. The epoxy resin base will be printed in honeycomb structure to maximize the absorption of electromagnetic wave by having multiple reflection in sample. The honeycomb structure will also minimize the material cost where 3D printer is used to obtain an adaptive size composite and is easier to be used in our daily life. Perhaps an effective device can be obtained. Field emission scanning electron microscope FESEM and vector network analyzer VNA will be used to analyze the morphological and microwave characterization performance of the material chosen in our prototype. Hence, the material is probably could be used to decrease the electromagnetic interference which is harmful to our health, and it can be used in various applications. Nickel zinc ferrite seem to be potential to be an electromagnetic wave absorbing material as it has high magnetic permeability, high resistivity and low eddy current loss. The material used also will be added with carbonyl iron where it helps to produce a great electromagnetic absorber. The honeycomb structure is implemented because it plays an important role in determining the best structure to maximize the absorption of the electromagnetic interference. So for the method part, it is divided to two phases, which is the first one is fabrication of synthesized carbon nanofibers. Nickel zinc ferrite nanopowder will be produced by using high energy ball milling apparatus. The mill powders then will be sintered at 9000 degrees Celsius for 10 hours. The nickel zinc ferrite will be further mixed with carbonyl iron and used as catalyst to grow carbon nanofibers. An ethanol solution is used as the carbon source to grow the carbon nanofibers by chemical vapor deposition method. Argon gas at 100 SCCM will be flushed into the closed furnace to eliminate air. The ethanol solution will be fluid for 30 minutes. After that, the furnace will be left to cool until room temperature. Finally, the samples can be used for the fabrication of the 3D printed honeycomb composite structure. The second phase is the fabrication of the composites. The synthesized carbon nanofibers will be poured into an epoxy resin base. The epoxy resin base composite will be printed at thicknesses fixed to 1 mm and 2 mm using 3D printer in the form of honeycomb structure. After that, we could see the results where the carbon nanofibers catalyzed from the mixture of nickel zinc ferrite and carbonyl iron can absorb the electromagnetic interference. and it can be used as an electromagnetic wave absorbing material. The morphological properties of the as-synthesized carbon nanofibers epoxy resin 3D printed honeycomb structure make the composite as a lightweight and flexible low-cost product that can increase the rate of the electromagnetic absorption. Finally, we could conclude that the mixture of the nickel, zinc ferrite and carbonyl iron used as catalysts to grow carbon nanofibers can be a potential candidate as an effective electromagnetic wave absorbing material. The properties of nickel, zinc ferrite, carbonyl iron 3D printed honeycomb structure makes it an effective absorbing material and has high potential to improve other electromagnetic wave absorbing material. I think that's all from me. Thank you.